In this video, we're going to take a look at exam revision for probability. So let's just jump straight into the first question here. What we've got now is 9 marbles in a bag. 4 of the marbles are red, 2 of the marbles are blue, and then the remaining 3 are green. Now 1 marble selected at random from the box, so for part A, we just want to write down the probability that the marble is blue. So we're looking for the probability of a blue marble. So how do we actually do this? Well, what we need here would be what we call a successful event, so that would be getting a blue marble out of the total number of possible outcomes. So what I'm looking for here is how many blue marbles do we have? So in that case, looking at our description here, we've got 2 of the marbles are blue, so we can pick 2 possible blue marbles out of how many marbles in total. So in that case, we know there's 9 marbles in a bag. So in that case, the probability of getting a blue marble would be 2 out of 9. Okay. The easy way to think about it is if you were to put your hand into the bag, well, there's 2 marbles that we could possibly pick out that are blue, and there's 9 in total. So in that case, we get 2 out of 9 there. Okay, so that's our solution to part A. For part B then, we're asked to write in the probability that the marble is red. So same idea again. So for the probability of red here, what we need to think about now is how many possible red marbles is there? Well, looking at our description here, we know 4 of the marbles are red. So we can pick 4 possible red marbles out of how many in total. And again, that total doesn't change. That will just be 9 still. So we get 4 out of 9 there. Okay, so that's our solution to part B. And for part C then, we're asked to write down the probability that the marble is yellow. So we're looking for the probability of a yellow marble. Now, part C is a little bit of a trick question because if we look at the actual description of the question here, we've got 4 of the marbles are red, 2 of the marbles are blue, and 3 of the marbles are green. Well, 4 plus 3 is 7, plus 2 is 9. So that's 9 marbles in total. But in that case, that means we only have red, blue, and green marbles. So there is no possible yellow marbles. If you put your hand in the bag and play out any marble, we'll never get a yellow marble. So in that case, we've got 0 possible choices out of 9. And in that case, 0 over 9 is the same as 0. Okay, so the probability of getting a yellow marble would be 0. It's impossible. Okay, and that's our solution to part C. Moving on to the next question here then, what I've got now is a list of 6 numbers here, and one of these numbers is chosen at random. So for part A, we're asked to write down the probability that the number selected is 3. So if I pick one of these numbers at random, what's the probability that the number I pick is 3? Well, how many 3s do we have here? So we're looking for the probability of getting a 3. So getting a 3. Well, I've got 1 3 here, and then I've got 5, 10, 6, 14, 21. So there's no other 3. So there's only one possible 3 here. That would be our numerator. And for the denominator then, that's how many numbers we have in total. And we're told that at the beginning of the question. There's 6 possible numbers here. So in that case, the probability of getting a 3 is 1 out of 6 there. Okay, and that's our solution to part A. For part B, we're asked to write down the probability that the number selected is greater than 8. So if I pick this number at random, what I'm looking for here is what's the probability of that number being greater than 8. So how many possible numbers do we have here that are greater than 8? Well, 3 is smaller than 8, 5 is smaller than 8. I've got 10 here, so that's greater than 8. 6 is smaller than 8. I've got 14 and 21. So in that case, we've got 3 possible options here. So we're looking for the probability of greater than 8. So greater than 8. So in that case, like we said, we've got 3 possible options. So it's 3 possible options. Out of how many numbers in total? Well, that is 6. We get 3 out of 6. And we can simplify this. 3 out of 6 is the same as 1 over 2, which is a half. Okay, so a half there gives us our solution to part B. And for part C, then we're asked to write down the probability that the number selected is greater than 20. So we're looking for the probability of greater than 20. Let's just jot this down here. So greater than 20. Well, how many numbers here are greater than 20? Well, 3, 5, 10, smaller than 20, 6, 14 are also smaller. We just got this 21 here. Okay, so that one is greater than 20. So that means we've got 1 possible option out of how many numbers in total? Well, again, same as the 2 previous parts, that will be 6. So for part C, we also get 1 out of 6 there, and that gives the solution to the second question. Moving on to this question here then, what I've got now is a football team that can win, draw, or lose a match. The table here shows the probability of each outcome for the football team. So we've got the result here, so win, draw, or lose, and then we have the respective probability. So the probability that this team wins is 0.46. The probability of a draw we don't know, we're going to work that in a moment, but the probability of losing is 0.18. So we need to find the probability of a draw for the football team. So what we need to understand here is what these probabilities must add up to. So when we look at probability, probability is between 0 and 1. And for the total outcome here, that must add to 1. So they either win, draw, or lose, so that must equal 1. So in that case, what I'm saying then is 0.46 plus this here. If I just call this x, for example, so 0.46 plus x here, so plus x, plus the probability of losing, so 0.18, they must add to 1. Okay, so if I add these together then, well, 0.46 plus 0.18, that would give me 0.64, so I get x plus 0.64 here is equal to 1. And I just want x here now, so to solve this equation here, we just subtract 0.64 off both sides. Obviously, if the question does like to use your calculator, then it's a lot more simple. You can just put this into your calculator here, but doing it by hand isn't too challenging, I don't think. So x in this case is equal to 1. Now, because we're adding 0.64 here, to balance this equation, we subtract 0.64 off both sides. So 1 minus 0.64, and in that case, we're going to get 0.36 there. Okay, so the probability of a draw for the football team, so the probability of a draw is equal to 0.36 there. Okay, and there we have it. So that's our solution to that question. Let me just double check we haven't made a mistake. So 0.46 plus 0.18, 0.64, yeah, and then subtract that. Perfect. Okay, so there we have it. So that's our solution to that question. So for this question, we're told the probability of James winning a tennis match is 2 out of 3. So we're asked what the probability that James does not win the tennis match is. Same idea here again as what we did for this question. So we need to be aware that the outcome here of winning a tennis match or not winning the tennis match will add to 1. So in that case, the probability of winning plus the probability of not winning, they will add to 1. Okay. Now we don't know what the probability of winning is. The probability of not winning is. That's what we're going to work out here. But we know what the probability of winning is. That's 2 out of 3. If I say the probability of not winning is, say, x here, I've got 2 out of 3 plus x is going to be equal to 1 again. Okay, these two events must add to 1. So in that case, if we want x here, what I need to do now is balance this equation by subtracting 2 out of 3 or 2 over 3 off both sides. So therefore, x is going to be equal to 1 minus 2 over 3. And some basic work with fractions here. If I've got 1 minus 2 over 3, we need to get this over a common denominator. So x is going to be equal here to 1. This 1 becomes 3 out of 3, or 3 over 3, I should say. Well, 3 over 3 minus 2 over 3. And in that case, then, because they have a common denominator, we can just subtract from the numerator like this. So 3 minus 2 gives me 1. So we get 1 over 3 there. So the probability that James does not win the tennis match will be 1 over 3. And again, the idea here is these two events must add to 1. So he either wins or he doesn't win. In that case, it must add to 1. And I've just done 2 out of 3 plus x is equal to 1. And then just subtracted 2 over 3 from 1 there. Okay. So probability of not winning. Probability of not winning is equal to 1 out of 3 there. Okay, and there we have it. So that's our solution to that question. I'm moving on to the very last question here. What I've got now are colour counters that are placed into a bag, and the table here shows the probability of picking each colour at random. So we can have either purple counters, brown counters, green counters, red counters, or pink counters. So for part A, we want to work out the probability of picking a green counter. Same idea as what we've seen now for the previous two questions. So if I think about this question here, if I pick a counter out at random here, then it's going to either be brown, purple, green, red, or pink. So in that case, these colours must add to 1. Okay, so if I call this x here, this green, then 0.12 plus 0.98 plus x plus 0.35 plus 0.24 must add to 1. Okay, so let's just do that here. 0.12 plus 0.08 plus x plus 0.35 plus 0.24. Like I said, this must equal 1. Okay, so what I need to do now is just add all of these decimals here on the left-hand side together, simplify the left-hand side. Well, 0.12 plus 0.8, that's 0.2, so I've got 0.2 plus x plus 0.35 plus 0.24. That's all equal to 1 still. So we simplify here, 0.35 plus 0.24, so that's going to give me 0.59. So I get x plus 0.2 plus 0.59. Okay, and that's all equal to 1. So we're nearly there now. I'm doing this in quite a drawn out method. You can obviously skip to just working this out straight away, just so I kind of make it all clear. Then add 0.2 and 0.59 together, so I get x plus 0.79 is equal to 1. So finally, if we just want x here, we need to subtract 0.79 from both sides. So x is equal to 1 minus 0.79. And in this case then, for x, we're going to get 0.21 there. Okay. And now that's our solution to pi a. So the probability of getting a green counter, the probability of a green counter is equal to 0.21 there. So you can replace the x here if you want with 0.21. So that's part A. And for part B, we're asked to calculate the probability of picking a purple or pink counter. So how do we work this out? So the probability of purple or pink here, how do we do this? Well, if I think about it then, there's two things we need to consider. We need to consider the probability of a purple counter. So let's just highlight that here. Oops, I kind of went over it a little bit. Let me try that again. Let's try to do that a little bit near. So try that one more time. There we go, that's a bit near. So that's purple, and we also need pink here. Let's highlight that. Okay, so these are the two we need to consider here. So if we're looking for the probability of picking a purple or pink counter, well, in that case, that would just be the sum of these two individual probabilities. So that's going to be the probability of purple. It's probably a purple plus the probability of a pink counter. You don't need to show quite as much detail as I'm doing here. You could just go straight into 0.12 plus 0.24. But again, I just want to make sure the actual intuition here behind this is clear. So the probability of a purple counter is 0.12. That's 0.12. Probability of a pink counter is 0.24. And then if we add these together here, I'm going to get 0.36 there. Okay. So the probability of a purple or pink counter is 0.36. And there we have it. So that's our solution to part B. And that gives us the solution to that question. And that actually brings us to the end of this video on exam revision for probability. In the next video, we're going to take a look at exam revision for frequency polygons.